All right, so this is our video for section 1.1, which is gonna just kind of introduce us to how we look at angles. We're also gonna look at some angle measures, maybe adding and subtracting angles, and just kind of a general introductory section. So hopefully we'll learn some new things and maybe also see some things that we've seen before in the past. So let's just go ahead and jump right in. Okay. The first thing I want to talk about is when we talk about 2 points and how those 2 points can be connected with a line. So it asks here, if we have 2 points to determine a line, how many lines can you draw between points A and B? Well, if we have 2 points, we really can only draw one line, right? There's only one way to connect A and B, right? It's a unique line. We can't draw any other line to connect those two, right? I mean, I guess we could make a squiggly, but then it wouldn't be a nice linear line. So there's only one way, right? One unique way to connect 2 points. The next thing I want to point out, little blast from the past, is the difference between a line and a line segment. So if we had a line segment, we could demonstrate this again with A and B. A line segment has a defined start and stop point, right? So it begins at A and it ends at B. So anytime you see the word segment, we know that we have basically dots that cut off our line. There's not going to be any arrows showing that they keep going in both directions, which is true of a line, right? A line keeps going and going and going in both directions. A segment stops, right? And then a ray, which is what we're going to work more with, is rays and vectors in this class, has a starting point A, right? So here's our A, and it goes through a point B, but it doesn't stop. So our starting point is A, but then it goes through the point B and it continues on, okay? So just kind of getting used to some of the verbiage here and what we can expect when we're dealing with angles, right? All right, so let's go ahead and look at 2 line segments or 2 rays that have a common end point. So I'm going to go ahead and just draw a picture kind of to help us visualize this. So we're talking about 2 rays with a common endpoint. So let's say this is our common endpoint, right? We could call it A or whatever we want to call it. So we have this ray and maybe we have this ray. Okay, so we have 2 rays that have an endpoint in common. Okay, the vertex is the common endpoint of the lines or the rays. So in this case, that's our A point here, right? A vertex is that common endpoint. Okay. The next thing we need to look at is the initial side and the terminal side. Now, the initial side and the terminal side is determined by which type of angle you have. If you have a positive angle or if you have a negative angle. So to help me demonstrate this, I'm going to use 2 different Greek letters. Okay. So let's we'll look at a positive angle first, okay? And I'm going to call this positive angle alpha. So to draw an alpha, you can think of it as a little goldfish, a little Jesus fish, right? And a positive angle always has a rotation that is counterclockwise. So if I start at this bottom ray and I go counterclockwise, then this would be my alpha angle, okay? So if I'm looking at my alpha angle, notice it started at this bottom ray and it ended at this top ray. So that means that this bottom ray right here, this would be the initial side of alpha, right? Because this is the side where alpha started, right? The initial side. So when we talk about the initial side, what we're really saying is that that is the starting side, right? And then the terminal side, you can imagine, is the ending side. So this ray over here would be the terminal side of alpha, okay? Because it starts here, because it's a positive angle, we go counterclockwise up to where it ends on our terminal side, Okay, now that's defined for alpha, but we could have other angles, right? We could have a negative angle. Negative angles go go regular clockwise. So let's call this one, let's just make up an angle. We'll call it beta. Now to do a Greek beta, it's kind of like making a capital B, but it has kind of like a long stick, right? All right, so if we're going to look at a negative angle, we know that it goes clockwise, so beta would look more like this. Okay. So if we're looking at the angle beta, which happens to be negative, then that flips or interchanges our sides, right? Because notice beta starts up here. So this would be the initial side of beta, because that's where it started, and then beta ends down here at this ray, so this would be the terminal side of beta. And the reason I list two is the terminal and the initial side mean the same thing, no matter what kind of angle you have. The initial side is where it starts, right? The terminal side is the ending side. I guess I could write that up here, is our ending side. But to determine which side you start at and which side you end at, we need to know if we have a positive or a negative angle, okay? All right, so let's go ahead and look at some of our common angles. And before we do that, I know on the next page it goes over all these common angles. I'm going to skip over to page 3 for just a hot second, and I want to talk about an angle in standard position, and then we'll go over all those other ones, okay? So when we have an angle in standard position, the vertex is at the origin. So remember, the origin is the point 0, 0, right, on any rectangular coordinate system. So if I have an XY axis, the vertex is going to be right here at the origin, right? And the initial side of the always lies on the positive x-axis. So over here is our x-axis, right? That's our horizontal axis. So basically what we're saying is that our initial side always starts here, okay? And then if we're dealing with a positive angle, right? A positive angle would go counterclockwise, okay? If it's positive. If we have a negative angle, same thing, we still always start with our initial side on the positive x-axis. So here's my initial side, right? My vertex is always the origin, but if we have, this is for a positive angle, but for a negative angle, instead of going counterclockwise, we would go clockwise, right? Which would put us down here somewhere. Okay, so positive angles go counterclockwise, negative angles go clockwise. Okay, so I want to look at just some positive angles that we might be familiar with. So let's go back to page 2 and look at some of these common angles. So a 360-degree angle is one complete rotation in the counterclockwise direction. So if I have my XY axis, that means that I am starting right here at my x-axis and I'm going all the way around and ending back at that spot. Okay, this is 360 degrees. Okay, then 180 degrees would be half of a counterclockwise rotation, right? Because 180 is half of 360. We still start on the positive x-axis, but this time it would only take us halfway around a circle, right? So this is 180 degrees. And then we can keep going, right? 90 is half of 180. So instead of doing a full half circle, now we're just going to have this little quarter circle, right? So we start at the positive x-axis side, and that would take us up here. This is a 90-degree angle. Okay, and some of you may remember that, right? A 90-degree angle crosses at a perfect 90 degrees, right? So we denote that with a box a lot of times. All right, what about 270, right? 270, it's not going to be all the way around, right? Because that's 360, but it's going to be further than 180, right? Because it's bigger than 180. So what that ends up being is 3/4 of a counterclockwise rotation. So that means we're starting at our x-axis and we're going 3/4 of the way. Okay. So this is 270 degrees. And then 0, we just don't put anything. Because what happens if we are right here, we are not going any degrees, right? That means the initial and terminal sides correspond. So usually if it's 0, usually I'll just put a point and then I'll put 0 degrees because we didn't go anywhere, right? Okay, so let's go ahead and practice writing some of these angles. So all of these that we just went over on page 2 were positive angles. So we went counterclockwise with all of them, right? But if they had happened to say do a negative angle, then we would just go in a clockwise position, right? So just to throw out another example, if I had something like example negative 360 degrees, okay, the negative here, that tells me that I need to go clockwise, okay, instead of counterclockwise. So if I wanted to draw this one, I still start at the positive x-axis, but this time I would go clockwise and draw it this direction. Does that make sense? 360 degrees is still one full rotation, but if it's a positive 360, we rotate counterclockwise, sorry, I can't say it. And if it's a negative, that tells us that we're going to rotate clockwise, okay? All right, so let's look at this next page. So on page 3, here's my little reminder of which direction to go when it's positive or negative. So what I want y'all to do is I want y'all to try, just really quick, pause the video and see if you can graph each of these. I just want you to write an XY axis just like we did the ones on the last page and see if you can draw the angle in the correct direction, okay? So go ahead and pause the video, give that a whirl, and then if you get stuck or if you get finished, unpause it and we'll go through it, okay? Okay, let's see how you did. So I went ahead and just wrote a note on here for each one. If I see that it's a positive angle, I know I'm going counterclockwise. If it's a negative angle, I know I'm going clockwise. Okay, so I went ahead and just wrote that on each one. I'm not going to require you to write that on your worksheets and stuff, but when we're first learning this, it's not a bad idea to go ahead and write it in your notes so that you have that reminder. Okay, all right, so for 90 degrees, we're going in the positive direction. So again, we start on the positive x-axis and we're going up to 90 degrees, okay? And then we always label it, okay? Even though I know it's written here, it's really good form to always label your angle because sometimes we'll have more than one angle written within a coordinate system, and so we want to make sure that we know which one's which, okay? Our next one is negative. Negative tells me that I'm going to be going clockwise 180. Now 180, remember, is a half rotation. So I'm still starting at my positive x-axis and I'm going a full half rotation in the clockwise position. So this is negative 180 degrees. Okay. Our next one is 135. 135 is positive, so we're going to go counterclockwise. Okay. And remember, if we go a little bit of the way, this gives me 90, right? This gives me 180, and I'm somewhere in between, right? I'm at 135. 135 is about, well, it is 45 degrees past, so it's actually halfway in between. So I'm going to start over here, and I'm going to go ahead and draw my ray out so that I can show that this would give me 135 degrees. Okay, so if it's one of these nice quadrantal angles, meaning it's 0, 90, 180, or 270, we don't actually have to draw in the terminal side, right? Because it's already there. It's already drawn with the XY axis, right? But here, 135, we didn't have the terminal side shown. So we actually had to go ahead and draw that in. Okay, that makes sense? All right, and then our last one is a negative 30 degrees. Okay, negative means I'm going clockwise. And if I'm going in the negative direction, this would be negative 90, right? And this is 0 degrees. So I know I'm going to come down 30. So 30 is about a third of the way to 90. So I'm going to go ahead and draw in my terminal side. And I'm going to say this little bit here is a negative 30-degree angle. Okay. So hopefully we did okay. Feeling pretty strongly that y'all did okay on number 1 and number 2. And then hopefully I didn't lose you on number 3 and number 4. Okay. All right. So now let's go ahead and move on and talk about what it means to have coterminal angles. What makes two angles coterminal angles? Okay. A coterminal angle, or we know two angles are coterminal if their measures differ by 360 degrees or a multiple of 360 degrees. Okay, so let me give you a for instance. Let me draw a picture here. Let's look at like a 45-degree angle. Okay, a 45, here's 0, here's 90. So a 45-degree angle would be perfectly in the middle here, right? So I'm going to go ahead and draw out a 45-degree angle would look like this. Okay, so it starts on the positive x-axis, and the terminal side is this 45-degree, or this ray that's up at 45 degrees away from the positive x-axis. Okay, so if I have this and I want to find a coterminal angle, that means a coterminal angle would be one that differs by 360 degrees. So I could either add 360 degrees or I could subtract 360 degrees, right? So one way to do that is to complete an entire rotation, right? Because if I went ahead and went up to 45 degrees and then added a whole 360, right? That would be starting here. Whoops. Actually, I'm going to do it small. Going all the way around, right? And back up to 45, right? So if I went all the way around, if I differed by just adding 360 degrees to it, right? 360 degrees plus 45 makes that a 405-degree angle. So this is a 405-degree angle. And these two angles are coterminal because notice they both share the same terminal side, or where the angle ends, they end on this same ray. Does that make sense? This one ends at the 45 ray, this one ends at the 45 ray. Okay, so that's what we got by adding 450, but we could also do one by subtracting, or not 450, oh my gosh. That's what we got by adding 360, but we could also find one by subtracting 360. So we could go in the other direction, right? We could do 45 minus 360. And if I did 45 degrees and I subtracted 360, right, then that would leave me with a negative 315 degrees. Or if you want to see it visually, that would basically be starting here and going all the way around and ending at, again, that same ray. So this is negative 315 degrees. So the idea is that for an angle to be coterminal, it means, think about that terminal, coterminal, means that terminal side where the angle ends, right, is shared by all of these angles. And the way that we find them is by just adding or subtracting multiples of 360. So it might just be one 360. It could be 2 copies of 360, right? We could go around 2 more times or 3 times, and we're still going to end at the same purple ray. So all of those are going to be coterminal angles, okay? All right, so let's look at a little exercise here. It says list 3 positive angles, so I don't want any negative ones. List 3 positive angles that are coterminal with 45. So the first thing I'm going to do, I have my 45 here, right? I know that 45, and then I'm going to add 360. Because I know if I subtract 360, that's going to take me to a negative number, right? And it only wants positive angles. So 45 plus 360, we actually already did this one, right? That equals 405 degrees. And then I want 2 more. So now that I have that one, again, I could just add another 360. So you can just keep adding on. I could say this is my first positive one, right? And then I'm going to go ahead and add another 360 degrees to give me another positive angle that's coterminal. 405 degrees plus another 360 gives me 765 degrees. So that's my second positive coterminal angle. And again, it said I wanted 3, so I'm going to add another 360. So 765 plus another 360 is going to give me 1,125 degrees. Okay. And you can write this out like this. I'm totally fine with you showing me your steps like this. Or you could write it out as 45 degrees plus 360, and then we're doing 45 degrees plus 2 copies of 360, and then 45 degrees plus 3 copies of 360. Okay, so in other words, we add 1 360, we add 2 360s, we add 3 360s. Okay, however you want to show it, but I need to see what you did on an exam, okay, because if I see this problem that says list 3 positive angles that are coterminal with 45 and all you have are these 3 numbers, you're not going to get credit. I need to see that you added or subtracted 360. Okay. All right, so let's look at the next one. The next one says list 3 negative angles. So now we only want negative angles. So I'm going to go ahead and do this one. And then hopefully how I did these, you'll be able to do the examples below. Okay. So if I want negative angles, I'm going to start at 45 degrees, but instead of adding 360, this time I'm going to subtract 360. Right? If I subtract 360, I actually already did that one up here. That's going to give me a negative 315 degrees. Right? And then I'm going to go ahead and subtract another 360 degrees. If I subtract another 360 degrees, I'm going to get negative 675 degrees. Right? And then I'm going to go ahead and subtract another 360 degrees. So subtract one more copy of 360, that gives me negative 1,035 degrees. Okay. All right, so now we know how to find coterminal angles, right? If we want positive coterminal angles, we add 360. If we want negative, we just keep subtracting until we get down into negative numbers. So here's what we want to do for each of these, A, B, and C. It says list 2 positive angles. So I want 2 positive angles and 2 negative angles for each one. Okay, so I want to go ahead and show you. I'm going to do C, and then I'll let you do these 2. Okay, so look at negative 603 degrees. I want 2 negative angles that are coterminal to it and 2 positive. So I'm going to go ahead and start with negative 603 degrees. And since it's already negative, I'm going to see if I just add. I mean, I could subtract 360 and go further in the negative direction, but I'm going to go ahead and add because this is a pretty large negative number. So I'm going to add 360 degrees and see what that gives me. Negative 603 plus 360 gives me a negative 243 degrees. So that gives me one of the negative angles that I needed, right? But I need another negative. Now, if I add 360 again, that's going to turn this into a positive number, right? So it's not going to give me any more negatives. So before I keep adding, I'm actually going to go ahead and take this negative 603 degrees, and I'm going to subtract 360 degrees just so that I get one more negative angle, right? Is everybody okay with why I'm doing that? Because if I add another 360 to this, that's going to give me a positive number. and I want to make sure I get 2 negative angles before I move on to the positive ones. So I'm just going to go the other direction by subtracting. So negative 603 minus 360 gives me negative 963 degrees. Don't forget your little degree mark. Okay. All right, so here's my 2 negative ones. Now I need to find 2 positive ones. So now I'm going to go back up to this one, the 243, and I'm just going to take that negative 243 degrees and I'm going to add 360 to it. So negative 243 degrees, because I already know it's coterminal, plus another rotation or another revolution gives me a positive 117 degrees. Okay. And then I need one more positive one, right? Because we wanted 2 positives and 2 negatives. I have my 2 negatives. Now I need to come up with another positive one. So I'm going to take this 117 and I'm going to add 360 to it. So when I add those together, that's going to give me 477 degrees. Okay. All right, so I did part C. I want y'all to do part A and B. So come up with 2 positive and 2 negative angles. Our answers may differ just a little bit because notice on this one, I could have subtracted 360 twice to get 2 negative angles, right? So our answers may be a little bit different, but I want to make sure we all end up with 2 negatives and 2 positives. So go ahead and pause the video and work on A and B as practice problems. And when you're ready, unpause it and we'll go over them, okay? Okay, let's see how you did. All right, so on the first one, I started with the 1106 and I subtracted 360 to get 746 degrees. So that's one of my positive angles. I subtract 360 again, and that gave me 386 degrees. So there's another one of my positive angles. And now I need negative. So I'm going to keep subtracting. So I subtract 360 again, which gives me 26 degrees, which doesn't count as one of my negatives. But if you listed 26 degrees as one of your positive ones, that's totally fine, okay? But now I'm going to take that 26 and subtract 360 again, which then puts me down into my negative coterminal angles. And the first one is negative 334 degrees. And then again, I subtracted 360 to get down to negative 694 degrees. So all of these angles, both the positives and the negatives and this little 26, all have the same terminal side as this original angle that they gave us for part A. Okay. B, same thing. Now this one was already negative. So if it's already negative, sometimes I'll just go ahead and subtract to get another negative one, right? So notice I couldn't get another negative one by adding 360, right? Because if I were to start by adding 360, that automatically puts me into positive numbers. So to get my negative ones, I'm going to start off by subtracting 360, which gives me negative 510 degrees. And then I subtracted another revolution, right, or another rotation to get negative 870 degrees. Okay, so those are my 2 negatives. Now I don't want to keep going with this negative 870 because I would have to add a bunch of 360s to get back into the positive. So I'm going to go back to my original angle that was given, which is negative 150, and then I'm going to add 360. That puts me up at positive 210 degrees for my first positive coterminal angle. And then when I add 360 again, I get 570 degrees as my second positive coterminal angle. Okay, does that kind of make sense? So make sure you pay attention on your homework because sometimes it will just say list 2 coterminal angles. Or it might have multiple choice and you have to select the ones that are coterminal angles. Okay, or it might be like this one where it specifically says you need a positive and a negative, or 2 positives and 2 negatives. Okay, so make sure you're either adding 360 or subtracting 360 to get to those values that you need. Okay, all right, so now let's kind of talk about the types of angles that we have, because that's super duper important. Okay, so if theta, which this, I always thought of this like looking kind of like the little Pepsi symbol, but basically to draw a theta, some people just draw a circle with a line through it. Technically, it's a little bit of a curved line, kind of like a Pepsi or a yin yang. But a lot of times I'll draw it like this just because that's quicker and easier, and it designates it really, really well so that you know it's not a B or some weird zero or something like that, okay? So anyways, we call this theta. So theta is an acute angle if the measure of theta falls between 0 and 90 degrees, right? So if we have a 90-degree angle, right, any of these angles that are in here, anything between 0 degrees and 90 degrees, these are all considered to be acute angles, right? And the acute angles is how we're going to define our trig functions, okay? So I'm just going to make a note here. We will define trig functions, I'm going to abbreviate functions, based on acute angles. Okay, so when we get into defining our trig function values, we're only going to be talking about angles between 0 and 90, and then we'll be able to relate them to all of the angles in a full rotation based on how they're related. Okay. All right, so acute angles are very, very, very important to us, right? A right angle, we know, is when it has a measure of exactly 90 degrees. A straight angle we consider to be 180 degrees, right? Because it's like straight across from 0 all the way to 180. It's that half rotation, right? And then an obtuse angle is an angle that opens up larger than 90 degrees, but not further than 180, okay? So think about, here's our 90 degree, here's our 180. So if we're saying these are angles that are larger than 90, but less than 180, it would be anything that falls in this quadrant, right? All of these angles. Any of those angles that go from our original x-axis all the way past 90 and land over here somewhere between 90 and 180, okay? All right, so those are our types of angles. Then we also categorize angles by how they are related, okay? So there's two types of angles or relationships of angles that we're going to rely heavily on in this course. And the first one is complementary angles. Okay, anytime you hear the word complementary angles, it means that those two angles add up to 90 degrees. Okay, so for example, this would be something like a 30-degree angle and a 60-degree angle, right? Or maybe you have two 45-degree angles. Okay, those angles add up to 90 degrees. Okay, and this is what we call complementary angles. And this is the more common one that we're going to work with, is this relationship that they combine to 90 degrees. Okay, a little bit less common is supplementary angles. Okay, so this is a little bit less common, but same idea. If they're supplementary angles, that means that they add up to 180 degrees. Okay, so we're going to use this relationship to be able to solve one. So if it might be, we're trying to figure out the missing angle. So maybe if I tell you, well, I have two angles that are complementary and one of them is 60 degrees. Well, if I know one of them is 60 degrees and they're complementary, then that means they have to add up to 90. So all I would have to do is take 90 and subtract 60 to figure out that the other one is 30. Does that make sense? So we're just going to use that relationship. Okay. Now, so far we've listed all of our angles with degrees, right? We've talked about 90 degrees, 30 degrees, degrees. And for the longest time, up until you get to trig, most angles you only work with in degrees. But just like other units can be broken down into smaller things, angles can be broken down into smaller units as well. So here's our, for instance, or our similar ideology. Okay, measures of angles. Just like a dollar is equivalent to 4 quarters, right? And each quarter is equivalent to 25 pennies, meaning we could take a dollar, we could write it as 4 quarters, or we could even break that down further and say 4 quarters is the same as, 25 pennies per quarter. We have these ratios that help us convert to these different increments, right? Same thing like time. So time, we can go from an hour to minutes to seconds, right? So the smaller pieces of an angle, we actually call minutes and seconds. Now, it's super kind of confusing. Honestly, when I first looked at this, I was like, now why on God's green earth would we use minutes and seconds when we use minutes and seconds for time? So just know that these are degree minutes and degree seconds. This is not a time unit, okay? This is just what we happen to call that smaller piece of an angle, okay? And the way that we denote it so that we don't get confused, because usually if we write out minutes or we abbreviate that MIN, that's how we show time minutes. So to show degree minutes, we use an apostrophe, okay? So that means if I wanted to write a ratio, I could say that 1 degree is the same thing as 60 minutes, okay, right? Or I could write that 60 minutes is the same thing as 1 degree, okay? So instead of writing the words minutes, because that makes me think of time, we're going to denote it with this apostrophe, okay, which is the correct notation for angle measure, okay? And then we have a smaller unit, which is seconds, okay? Again, annoying because it sounds like time, right? But it helps us remember it because it's the same unit. It's still 60 seconds to a minute, 60 minutes to a degree measure. So the same thing, I would write this now. Seconds we denote with 2 apostrophes or like the quote symbol, right? So then we can say that 1 minute is the same thing as 60 seconds, right? Or 60 seconds is the same thing as 1 minute. So we're going to use these ratios to help us convert things. How can I describe it? Let's say we're talking about time, since these are kind of related. I would not say, hey, I'm going to come over to your house in 1 3/4 hour, right? We don't say 1 3/4 hour. We say 1 hour and 45 minutes, right? Because 45 minutes is 3/4 of an hour. So it makes more sense to say, here's how many total hours we have, and then our partial hour we change to minutes, right? You say, I'm not going to see you in 1 3/4 hour. You say, I'm going to see you in 1 hour and 45 minutes. Well, the same thing is true with angles. If we say, oh, I have a 30.27 degree angle, that's kind of hard to, that doesn't really make sense. So what we're going to do is we're going to say if it's 30.27, we're going to go ahead and leave the 30 because it's a whole unit as degrees, but that 0.27, because it's a partial degree, we're going to change that to minutes, okay? So that's where we're headed. Let's look and see. We're going to use baby steps to get there first. I want to make sure that we can, that we realize these are just angle measures, so we can add and subtract them just like we normally would degrees, right? So we're going to do these following computations just to get a little bit of practice. Now, anytime you add and subtract, it really helps to line it up. So I'm going to rewrite this as 60 degrees, 45 minutes, plus 13 degrees, 20 minutes. Okay, so we line it up and we just add straight down. It's like adding common units, right? So I'm going to add my minutes together first. So 5 and 0 gives me 5. 4 and 2 gives me 6. So I have 65 minutes. And then I add my degrees, right? 60 degrees and 13 degrees gives me 73 degrees. Now, normally this would just be my answer, and I would circle it and say, yay, we ended up with 73 degrees and 65 minutes. But this really doesn't make sense to leave this as 65, right? Because we know, right, we know that 60 minutes is equivalent to 1 degree. Does that make sense? So I want to convert this. It's like saying when we're adding regular numbers, we don't talk about having 10 ones, right? If we have 10 ones, we just put a 0 in the ones place and we carry the 1 over to the tens column, right? So the same thing here. Once we get 60 minutes, we can convert that to an hour. So I'm going to move 60 of my minutes over here and add a degree, if that makes sense. Okay, so then what I end up with, 73 degrees plus this 1 degree I moved over, gives me 74 degrees. And then once I move that 60 minutes away, that left me with just 5 minutes. Okay, so this ends up being 74 degrees, 5 minutes. Okay, so I want y'all to take a second, pause the video, and I want you to try to add these two measures together. Okay, same idea. This one just has degrees, minutes, and seconds. So go ahead and pause the video, add these two together, and then if you get stuck or if you get done and you're ready to check yourself, unpause it and we'll see how you did, okay? Okay, are you ready? So let's see how you did. When we added our 31 degrees, 10 minutes, 18 seconds to 20 degrees, 15 minutes, 45 seconds, we end up with 51 degrees, 25 minutes, and 63 seconds. Right? But notice we ended up with over 60. So again, okay, now we can convert our seconds into a minute, right? So it takes 60 seconds to equal 1 minute. So I can think of subtracting these 60 and moving it over and adding 1 minute. Does that make sense? Okay, and I don't care if you show this, I'm just visually showing it for those of you who are visual learners. So this leaves me with 51 degrees. That's going to give me 26 minutes. And then because I took away 60 of these seconds to turn it into a minute, I only have 3 seconds left. Okay. And when you enter these on My Math Lab, there are no spaces here. Okay, you write it all together, just 51 degrees, 26 minutes, 3 seconds. Okay? All right, so now let's look at finding supplements or complements given certain angles. Okay, so I'm going to do 2, and then I'm going to have y'all try 1, I believe. Okay, so for example, first of all, we need to remember what supplement and complement means, right? So the supplement means that they add, the two angles add up to 180 degrees, okay? So it says we want to find the supplement of the following angles. So if the first angle is 90 degrees and we're trying to find the supplement angle, what we're trying to find is what angle, when we add it to 90 degrees, gives us 180 degrees, right? Or in other words, what angle plus 90 degrees equals 180 degrees, right? And in order to add that, in order to solve that, all we have to do is subtract our 90 degrees, right? Which I think most of you knew, to just do 180 minus 90 gives us 90, right? The supplement angle of 90 degrees is 90 degrees because 90 plus 90 equals 180, right? But it's a little bit maybe more work when we're dealing with degrees and minutes, okay? If we want to find the supplement of this, we're still going to take 180 degrees and subtract the angle that's given. Just like here we took 180 and we subtracted 90, right? Here we're going to take 180 and we're going to subtract 45 degrees, 3 minutes. The problem is, though, I don't have any minutes here. And so just like when we do normal subtraction, if we don't have enough tens or ones or whatever, we can borrow, right? So I'm going to borrow a degree from here, right? Now, if I borrow a degree from 180, and I'm going to say, let's just say, we're going to borrow 1 degree, okay? So I'm going to rewrite this. If I borrow a degree from 180, that means I'm only going to have 179 degrees now, right? And that 1 degree that I borrowed is equivalent to 60 minutes. Okay, everybody okay with what I did there? Okay, I'm just borrowing a degree so that I can write it in minute form so that I can do this subtraction. So now I'm going to go ahead and rewrite my minus 45 degrees 3 minutes. And now I can go ahead and move on. Okay, so if I do 60 minutes minus 3 minutes, that gives me 57 minutes. And then 179 minus 45 leaves me with 134 degrees. So I end up with 134 degrees and 57 minutes. Okay. All right. So I want to challenge you a little bit to do this next one. Okay. I'm going to give you a little bit of a hint because this one's different than the last two we did because it doesn't say supplement. Right, remember supplement angles add to 180. This one says find the complement. So remember the complement angles add to 90 degrees. So I'm going to go ahead and list this as a practice problem. I want you to go ahead and pause the video, give this one a whirl, and then when you're ready, unpause it and we'll see how you did. Okay? Okay, let's see how you did. So first thing we want to do is we want to write it lined up, right? So if we're trying to find the complement, we're trying to figure out what angle, when I add it to this angle, gives me 90 degrees. And the easiest way to do that is to just take the given angle and subtract it from 90 degrees. So I have my 90 degrees and I'm subtracting this angle that they gave me, but I have an issue, right? I don't have any minutes here. So I'm going to borrow 1 degree. So I'm going to take that degree away from the 90 degrees, which makes it 89 degrees. And I'm going to write that borrowed degree as 60 minutes. Okay. So now I have 89 degrees, 60 minutes, and I'm subtracting my given angle. But I have another issue, right? My second issue is I don't have any seconds. So now I'm going to borrow one of these 60 minutes in order to be able to write some seconds here. So I still have my 89 degrees. When I borrow a minute, it's going to become 59 minutes, and I can write that borrowed minute as 60 seconds, right? And now that I have something in place for each unit, right, then I can go ahead and subtract my angle measure. Okay. When I subtract, I end up with 29 degrees. My minutes actually cancel out, right? And I'm left with 49 seconds. So if that happens, you can just enter it as 29 degrees, 49 seconds. You don't have to put in 0 minutes. Okay? Okay. Hopefully you aren't horribly offended by that. So the last thing I want to look at is using ratios to convert degrees into minutes and seconds, or excuse me, if we're given minutes and seconds, to be able to convert that back to degrees. Okay, so let's look at that last little topic, and then that will be the end of this section, and you'll be able to get started on your first homework assignment. Whoop whoop. All right, so this says convert 30 minutes to degrees. Now, whatever we're converting it to, that's what we want to end up with on top of our fractions. Okay, so we want to end up with degrees. So I'm going to go ahead and just write over here to the side. Okay, some of our helpful ratios. Okay, helpful ratios is we know that 1 degree is 60 minutes, right? Or 60 minutes is 1 degree. We also know that 1 minute is 60 seconds, or 60 seconds is 1 minute. Okay, so I'm just gonna write this as like kind of like a little box off to the side that we can reference. Okay, so if we want to convert this to degrees, we want to make sure that degrees is on the top of our fraction. So here's my two ratios with degrees. Because I want to end up with degrees, I want to use the one where the degrees is on the top. Okay, So I have 1 degree is the same thing as 60 minutes. So that's the ratio that I want to use to multiply my 30 minutes by. So I do 30 minutes times 1 degree over 60 minutes. And the reason that I'm doing that is because now my minutes unit will cancel, right? So when I cancel that, I end up with 30 degrees over 60, and then 30 divided by 60, right? That's half. Or in other words, I could write this as 0.5 degrees. And I just leave it like that. Okay, make sure on exams or worksheets or anything that gets turned into me, you show me how you converted it. Again, if it just says convert 30 minutes to degrees and you just have this as your answer and you don't show me that you did any kind of conversion, no credit, okay? All right, let's look at this next one. This one says convert 45 degrees, 30 minutes to degrees. Now again, we want to end up with degrees, but actually part of this is already in degrees, right? We have 45 degrees already and then 30 minutes. So I'm going to rewrite this. Instead of writing this as 45 degrees, 30 minutes, I'm just going to rewrite this as 45 degrees plus 30 minutes, right? We agree that's the same thing, right? I'm just separating it because really I only need to convert this piece because 45 is already in degrees. So I'm going to convert 30 minutes to degrees. Since I want it to end with degrees, again, I'm going to use this first ratio where degrees is on top. So I'm going to multiply by 1 degree over 60 minutes, right? And then again, my minutes are going to cancel, and that's going to give me 45 degrees plus 30 over 60 degrees, right? And then we know that 30 over 60 is 0.5. So 45 degrees plus 0.5 degrees. And now that they're both in degrees, we can just add them together. So this gives me 45.5 degrees. Okay. Does that kind of make sense? I know that this little thing we had to convert was the same as the one we did above. I just want to show you if we just have minutes, we can convert it to degrees. If we have degrees and minutes, again, we're just converting the minutes piece, and however many degrees that ends up being, then we just add it to our existing degrees. Okay? All right, let's see. I'm going to go ahead and let y'all try the next two. Yes, I'm going to let you try the next two. And let's see how that goes. So let's go ahead and put these as practice. So go ahead and pause the video. And here we're starting out with minutes. We want to convert it to degrees. This is very similar to part A that I did above. And then part B, we might have to do a little extra work, right? Because we're going all the way from seconds to degrees. So go ahead and pause it. Give it a go, and then unpause and we'll talk about it, okay? Okay, let's see how you did. On the first one, we're going from minutes to degrees. So because we're going 2 degrees, we want degrees on top. So we're going to use our ratio that 1 degree is the same as 60 minutes. That way our minutes unit will cancel. We multiply straight across, which gives us 25 over 60 degrees. And then we go ahead and put it in decimal form, which gives us 0.42 degrees, okay? On the second one, we have to do a little bit more work, right? Because this one's starting at seconds. So again, we want to end up at degrees. So we're starting with 17 seconds. So if we want this seconds to cancel out, we need a seconds on the bottom, right? And we know that there's 60 seconds in 1 minute. So I'm going to use this ratio so that my seconds will cancel out. And then I don't want to stop there because I need to go all the way to degrees. So then I need to convert from minutes to degrees. So I have minutes on top here. In order to cancel that minutes out, I need minutes on the bottom over here. So I know that 60 minutes is the same as 1 degree unit, right? and that will allow me to cancel out my minutes. Okay, so once I've canceled my units out, then I can go ahead and multiply straight across. So I end up with 17 over 3600 degrees. And then I'm going to go ahead and change that or convert it into decimal form, which gives me 0.0047 degrees. Okay. All right. So now we want to look at going the opposite way. This was starting with minutes and going to degrees. Now we want to look at starting with degrees and going to minutes. Okay. So I'm going to look at a couple more examples, and then I'll show you a word problem, and then we'll be done. Okay. All right. So we want to convert 0.25 degrees to minutes. So I'm going to go ahead and write my 0.25 degrees. And remember, I want to end up with minutes. So I want my minutes unit on the top. So remember, I have 60 minutes in 1 degree. And if my degrees are going to cancel, my 1 degree needs to be on the bottom. And then the minutes that I want to end up with need to be on the top. You know, there's 60 minutes in 1 degree. And then I can go ahead and cancel my degrees, right? And 0.25 times 60, or a fourth of 60, gives me 15 minutes. Okay, not too bad. The hardest part in these, really, when we do these conversions, is just knowing how to write the ratio, whether to put degrees on top or minutes on top. And it really depends on what you're starting with and what you want to end up with. Okay, let's look at another one. This one says convert 16.25 degrees to minutes and seconds as is appropriate. So we want to end up with degrees, minutes, and seconds if we need to go that far. Okay, now right now this is written in degrees. So if I have whole degrees, I want to leave those alone. So I'm going to go ahead and rewrite this as 16 degrees, because 16 is already nice, full, wholesome degrees, right? What I need to convert is this partial degree, or the 0.25 degree, right? And in order to convert that, I would just need to multiply by a ratio that takes me from degrees to minutes, right? Now, luckily, if you notice here, this is exactly what we just did in the previous problem. So I'm just going to say, look at part A that we just did. We just figured out that a quarter degree is the same as 15 minutes, right? So this gives me 16 degrees plus 15 minutes, just using our work from above. And then we don't want to leave it with the plus sign in there. So we're going to go ahead and just write this as 16 degrees, 15 minutes. And notice we don't have any more decimals. So we don't have any more partial pieces. We don't have any partial degrees. We don't have any partial minutes. So we're going to stop here. If I ended up with something funky like 15.5 minutes, then I could take that partial minute and break it down to seconds. But in this case, I don't have any more decimals, so I'm good. We can just stop there. Okay? All right. Last page. Last page. Okay. So, I'm trying to decide if I want to do this one step at a time. I think I'm gonna do this all as one problem. Notice what it's saying is to take this. This is a partial degree, right? I want to take this partial degree and turn it into minutes. And then the second part says take that same partial degree and change it to minutes and seconds. And then they give us 16.27 and they want us to change it to minutes, seconds, blah, blah, blah. So it's kind of just building up to part C. So I'm going to combine all this. I'm going to mark these out. And I'm just going to say we're going to convert this to minutes and seconds as appropriate. Okay? Because it's all in degrees right now, right? And I want it in minutes and seconds. Notice it doesn't say I want degrees. So even that 16 that full degree is going to have to be changed into minutes and seconds. So I'm going to take 16.27 degrees, and to change it to minutes, I'll worry about seconds here in a minute. To change it to minutes, I need to use a ratio that has minutes on the top. So in order to get a ratio with minutes on the top, my degree is going to have to be on the bottom. So in 1 degree, I have 60 minutes. Okay, so let's go ahead and multiply this. Notice right away we can see that our degree is going to cancel, so we're not left with degrees. Okay, so I need to do 16.27 times 60, which gives me 976.2 minutes. Okay, so it wanted us to convert 16.27 to minutes and seconds. So what we've done is we've converted it to minutes. Okay, but notice we have this 0.2. We have a partial minute, right? So I'm going to go ahead and rewrite this as 976 minutes plus this little 0.2, which is a partial minute. And then I'm going to convert just that little partial minute into seconds. Okay, so to change this into seconds, I'm going to multiply by a ratio that will cancel out the minutes. So minutes needs to be on the bottom. So in 1 minute, I can change that into 60 seconds. Okay, is everybody kind of okay with me? I changed degrees to minutes. And if I would have just come out with nice, pretty, like say 978 minutes, I'd be done. But since I ended up with a partial minute, that partial minute I need to change to seconds. Okay, so I still have my 976 minutes plus, over here I can see now that my minutes are going to cancel, and 0.2 times 60 gives me 12 seconds. Okay, and then the last thing I have to do is just write this together without the plus sign. So I have 976 minutes, 12 seconds. And that's really the goal, is to end up with no decimals, right? To have it broken down nicely. So make sure, again, you're paying attention to your instructions, because if it had it said degrees and minutes and seconds, you wouldn't have had to convert the 16. You would have left the 16 alone, and you would have only converted the 0.27. Okay, so always make sure you pay attention to what it wants you to end up with. Okay. All right, last problem. How can we apply this? Why do we care? Right? So here's an example application problem. It says a wheel makes 270 revolutions per minute. Through how many degrees will a point on the edge of the wheel move in 5 seconds? Okay, so let's write down what we know. First sentence. A wheel makes 270 revolutions per minute. Now I'm just going to go ahead and write that as a ratio. 270 revolutions per 1 minute. Now notice I'm writing MIN because this is talking about time. It's not talking about angle minutes. Okay, so 270 revolutions per minute is my ratio. Now I'm going to write it like this, or it may be that I want to write it as 1 minute over 270 revolutions. Okay, just depends on what I want to end up with. Okay, so what it's asking me is through how many degrees? How many degrees is what it's asking me. So that means I want to end up with degrees. Okay, so first thing, before I even talk about the seconds, I need this to be into degrees, right? And right now it's in revolutions. So we're talking about a wheel, right? Here's a wheel, and it's going around however many revolutions per second. And what we're doing is we're just going to pick a spot on that wheel, and we're going to wait for 5 seconds and see how many times will it go around in 5 seconds, right? Through how many degrees, actually, not how many seconds. How many degrees will it have traveled in 5 seconds? Okay, so the first thing I want to do is make sure that it's in degrees. So I don't really want it to be written in revolutions. Even though a revolution I know is 1 full turn, I can represent that in degrees, right? So I want degrees to be on top, right? And I know that degrees and revolutions are equivalent, right? I know that it takes 360 degrees to make one full revolution. Revolution. Right? All right, so if I look at my two ratios that I came up with here I have revolutions on bottom. So if I want that to cancel out, I'm going to use the one that has the revolutions on top. So I'm going to write this as 270 revolutions over 1 minute. Okay, so I don't need this one. All right, so let's go ahead and multiply that. And notice here my revolutions are going to cancel, and what I'm going to be left with is degrees per minute. Okay, so when I multiply 270 and 360, what I'm going to get is 97,200 degrees per minute. Okay, all right. So let's go back and make sure I know what I'm talking about. It does want to know through how many degrees. So our answer should be degrees, right? But it wants to know how many degrees has that spot on the wheel moved in 5 seconds, right? So we don't want it in minutes, we need it in seconds. So now I'm going to go ahead and I'm just going to put a line here, convert to seconds. Okay, so I want seconds to be on top because that's what I want to end up with, right? No, I need seconds on the bottom, sorry, because I want it degrees per second. My degrees is on top per second. There we go. So then I have minutes on top so that these two will cancel. So in 1 minute, we know that there are 60 seconds, right? And this helps us out because now our minutes cancel, right? So when I multiply across, I think this comes out nicely. I think 60 actually goes into that number. So 60 into 97,200 gives me 1,620 degrees per second. Okay, so we're almost there. We're almost there. So now we know the rate at which this point on the wheel is moving around. It's moving around at 1,620 degrees per second. But remember here, it wants to know how many degrees will it have moved in 5 seconds. So now that we know the rate, now all we have to do is multiply that times 5 seconds. Okay, when we multiply it by 5 seconds, our seconds cancel. 1620 times 5 gives us 8,100 degrees. So that is a lot of degrees, right? So that means on this wheel that's going around, if we pick some point, it will have gone around an equivalent of 8,100 degrees in 5 seconds. Does that make sense? Okay. All right, so we're going to go ahead and stop there. That is the end of section 1.1. So you should now be able to complete that assignment. If you have any questions, please let me know.